Hello viewers, in today's class we are going to discuss one important and conceptual problem from functional equations, right? So here we have a problem in which the concept of functional equations and the concept of derivative both are used, right? So let us first read out the problem. So here we are given a function f which is differentiable function, right? And the property of the function is such that f of x plus y is equal to f of x plus f of y plus the product of x and y, right? So this is a functional equation, right? Connecting x and y, right? So f is a differentiable function which we are given such that the function f, it obeys this property, right? And moreover we are given that limit h tends to 0, 1 over h, f of h is equal to 3. Then we have to find the form of the function f of x, right? So to solve this problem, what we will do, we'll take help of the definition of the derivative of a function, right? The definition of the derivative of f of x, right? So we know that the derivative of a function f of x is defined by this limit, that is a limit h tends to 0, and we have f of x plus h minus f of x divided by h, right? Where h is infinitesimally very small quantity, right? So we'll solve this problem by using this equation or using the definition of derivative of a function. So now see here we have to find the form of the function f of x, right? So here what we will do, we'll try to integrate this equation in both the sides, right? Because here we have the derivative f prime of x, which can also be written as the df over dx, right? So now let us move further from this equation, right? So here we have f prime of x. Now see, we have limit h tends to 0, and here we have f of x plus h. Now see, here we have f of x plus y. So now if we replace this y by h, then we have the expression for f of x plus h, which can be written as f of x plus f of h, and here we have x of x times h, right? So f of x plus h can be replaced by this expression by using this functional equation. So here we have f of x plus f of h plus xh minus this quantity f of x, right? And we can divide it by h, right? Okay, now f of x and f of x get cancelled. We are left with limit h tends to 0. We have f of h plus xh divided by h. Now let us distribute this h in the denominator of f of h and xh. So we can now write limit h tends to 0. We have f of h divided by h plus xh divided by h, right? So now f prime of x can be written as the limit h tends to 0. We have f of h over h plus this h and this h get cancelled, so we are left with x, right? Now we have this equation. Okay, so now see, we are given this limit, that is limit h tends to 0, 1 over h, f of h is equal to 3. So what we will do here, we'll replace this limit by 3, right? So we have f prime of x is equal to 3 plus x. So now see, we have got a differential equation. So f prime of x is equal to 3 plus x, because this limit h tends to 0, f of h over h is replaced by 3. So now let us replace f prime of x by df over dx, and here we have 3 plus x. Now integrating both sides, so we have df, and here integral 3 plus x dx, right? So the integral of df is simply f, and here we have 3x and x square over 2. The derivative of 3 dx is 3x, and derivative of x is integral of x is x square over 2, right? And here we have the constant of integration, right? So now the form of the function f of x is quadratic, right? So we have f of x, because this is f, which is f of x. So f of x is x square over 2 plus 3x plus c. Now our aim is to find out this constant of integration c, that is the value of c. So now let us apply the boundary conditions here. So what we will do, we'll take x is equal to 0 and y is equal to 0 in this functional equation. So we'll get f of 0 plus 0. Here we'll take x is equal to 0 and y is equal to 0. So we have f of 0 plus 0. Here we have f of 0. Here we have f of 0, and here we have 0 times 0, right? So 0 plus 0 is 0, so we have f of 0. This is 2 times f of 0, and here we have 0 times 0 is 0, which is 2 times f of 0, right? So now we can solve this equation for f of 0. So we have 2f of 0 minus f of 0 is equal to 0. So this implies f of 0 is equal to 0, right? So we have obtained that when x is equal to 0, f of 0 is equal to 0. So let us apply this condition to this equation. So taking x is equal to 0, here we have f of 0. So this is 0 square over 2 plus 3 times 0 plus c. So this is 0, this is 0. So we have the c plus 0, that is simply c, and f of 0 is 0. So we have 0 is equal to c, that is the value of c is 0, right? Now taking this value of c as 0 in this equation, we have f of x is equal to x square over 2 plus 3x, right? Because the value of c is not going to contribute, right? So f of x is a quadratic function here. This is a polynomial function. So the form of the function f of x which satisfies this functional equation, and this limit is a quadratic function.